Hi. So this video would be for going over our implementation deployment of a Python library, which basically converts dicom to FHIR objects, dicom images. So basically, it's an open source Python library that accepts a directory as an input, and that directory is supposed to contain dicom images. And what the library does is it processes all the files within that directory. It does expect that the directory will only contain files from a single dicom study case and not multiple cases. If it does find something like that, it would throw out an exception. And but if it's unable to find a file which is, or rather, if it's not able to read the file, it will just keep on skipping the files and move further down the study. And the library is utilizing two pre-existing Python libraries. One is right here, the FHIR resources, and another one being the PyDcom library. It's a pretty cool and interesting project, again, open source, which simplifies the ability to read dicom instances. And of course, the fire resources is used to create fire models based on fire objects. So basically, the entire library is composed of two separate modules. The first one being the dicom2fhir utilities.python, as we can see on screen. And it basically imports a bunch of libraries from the fire resources, mostly imaging study identifier, codable concept, coding, patient human name, fire date and reference, and it does specify the coding system as well to HL7, and it also sets the modality for base calculations. As you can see, it has a bunch of functions in it. The ones that we're looking at are generate accession identifier, study instance UID identifier, get patient resource IDs, calculation of gender, calculation date of birth, and inline patient resource, generation of procedure code and array, and generation of started date time, the reason for the study, the modality coding, and the modality listing. And yeah, the SOP class and generating of coding as well. So these are the various functions that are used to generate the study. And basically, the input file, what it does is that it represents a single instance within the dicom study, like I just mentioned. And they can also be grouped by series. And we also have a built-in function within the library to handle that as well. And that's the first module. And the second module that we have is basically invoking the dicom2fhir utils that we already saw, in addition to some other libraries such as DCM read and dataset, which are coming from the PyDcom open source library. The libraries that I mentioned, they are all within the requirements.txt, so they would need prior installation. If they are not present, obviously the build and the eventual deployment and testing would fail. It does need the setup tools version 50.3.2, which is probably a bit older than what the current version is, so it has to be explicitly installed at that version for this whole library to function. Now, this is the main function, which references the directory under which the dicom images are sitting and starts reading them instance by instance and converts them into the respective fire objects. So the imaging study itself is being generated internally within the library, and uh, it's meant to be like self-inclusive to mimic the dicom structure. And the basic usage of the entire library is via a function, which is the uh, just a second, which is the process dicom2fhir function, and that's the function that's gonna be invoked. Yep. So this is the one that actually does the post generation processing and gives out a JSON output. So uh, those are the two core modules within the library, and I have a few test modules that I'm gonna run right now, which basically reference some sample dicom data samples, dicom images, and I have like one each that came from a free reference over the internet that's meant to be for research and testing purposes. So basically we're trying to see each case of how the data is handled, one for test multi-instance, one for series, and one for single. So I have all of the requirements pre-installed on my machine, and I've made sure all of the imports work correctly. So I will try to run my test cases, and hopefully they should go through fine. And the libraries are completely based in Python. I mean, there's no external requirement of any sorts. And yeah, there you see that the single instance processing and the series and the multi-instance and the multi-series, all three of them went through fine. And unfortunately, I don't have much sample data. I mean, that could be completely read by the libraries. So I just created a little test case here based on what was available. But yeah, I mean, the library is pretty flexible, and it runs as expected. I mean, the usage is pretty straightforward, and more information can be found in my project document. And yeah, this was just a quick run through with the deployment and the test cases of the library.